Welcome back to AI Search, the podcast about AI and ML in every industry. We're so excited to have Marko here today to talk a little bit about his career in transforming AI teams. Hey Marko, how are you doing today?
Hi, great. Thanks for having me here.
Yeah, it's great to talk to you. So tell me a little bit about your career and what have you been up to?
Well, I've been engineer, software engineer, machine learning engineer, and for the last 10 years or so, I've been engineering manager in domain of machine learning. I have experience in building machine learning teams. Worked here in Zagreb in Styria Media Company. We had some really early, I would say, deep learning things in production, awarded by NVIDIA. We had, like, in 2015, we had our own GPU deployment for some systems, recommender systems, object recognition for classifieds and so on. I also worked a couple of years as a consultant on machine learning projects for Lego. And I worked at Facebook for 2 years in London. And for the last 4 years, I've been at Photomat, and now for the last 1.5 years at Google, since Google acquired Photomat.
Yeah, very cool. So out of all, this is a really broad set of experience, and I've heard so many amazing things about Styria, and actually I have a few friends who came from there or worked through there, so it's just incredible to see what you guys have built way back before this whole AI hype was happening. What was one of your favorite projects that you worked on there, if you're allowed to share that?
Yeah, sure. There was a couple of projects. There was news recommendation system for the biggest creation news portal. That was interesting both in terms of machine learning models, but also in terms of deployment, since we had to serve such huge amounts of traffic as like the biggest news portal is 24 sata and 24 sata. And one also really cool project is for Njuškalo, classifieds app, where you can basically go around your house and real-time see on the camera overlay for how much you could sell something on this second-hand sales
I've used that one. Yeah, very cool. And you said you worked for Lego also, so this is interesting because I think it's such a product company and not a software company as much, but how did you guys end up using machine learning and AI in that?
Yeah, there is an entire unit at Lego working on digital products and trying to figure out how to combine digital products and experiences with the physical toy, since the kids are way too much distracted nowadays with different flashy screens, and it is great if we could combine like some kind of digital experience, but while keeping the kid mostly on the physical toy.
Cool.
In order for them to look less at screens, to satisfy that need, like to have something in digital world, but still have them motivated to keep playing with things in the real life, to develop all these sensory motorical skills, and actually to be able to pay attention on the real world things.
Yeah. Do you find that a problem, that children were kind of struggling with that, with the introduction of a lot of screens, that they weren't really able to focus on like old school toys? Like, I know I grew up with Lego and Playmobil, so that's what I know, and trains, but I think this generation's just online.
Yeah, I cannot speak in front of Lego, of course, but from my own experience, I think it's really tempting for parents to get some moments of relief by just putting the screen and, catch a break and take a breath. Because it's so challenging and draining for parents, especially nowadays, where all of us are working a lot, have less and less time and attention and energy to spend with kids, right? So I think it's really critical to consider long-term consequences of that. And for young people, young brains, losing ability to be focused in the real world on the task at hand could be really like damaging. So I think that's a really important thing to think about.
Yeah, very cool that you're on a team that was kind of trying to combat that very early on. Yeah, cool. You talked a lot about scaling teams, AI teams. How do you go about that? And like, how large does a team need to be to start implementing like a machine learning project or an AI project in like real world situations?
Yeah, there are two great questions, I think there. One is how to build ML team, and the second one is how many people. And I think that things changed in the last couple of years,
Okay.
especially with LLMs and all the help that is there. I think that now one person can be much more productive and have much more broad scope of skills.
True.
And not just have the skills, but be able to acquire them and implement quickly. And my philosophy, let's say, was always to build or to try to build end-to-end teams when it comes to ML products and services integration and so on. So what I mean by end-to-end, I mean that the one team is responsible of creating the data,
Okay.
or acquiring the data, owning it, making machine learning models, but also putting them into production, and owning what is in production. Because if you have this entire circle in one team, in one group of people, then they are all incentivized to take care of all these things.
Yeah.
And good, reliable, long-lasting machine learning system cannot live without being excellent in all these components, because for a real-world ML system, you need to ensure that you are dealing with the data drift, distribution shifts that are happening over time, that you are incorporating active learning, meaning that you pay attention to what the system is not working on, how do we acquire that data that is gap there, and how do we label it, how do we ensure that the model is growing as the system is growing and as the time is passing. And for how many people, I think, like I said, things may be changed there. Now I think you can have less people, and there are even cases where one person can build and has built amazing things in production. Especially with the use of all this coding help and problem solving, I would say, help with LLMs and so on.
Yeah.
If done right. So there are many nuances there and many pitfalls when using LLMs for coding. So one has to be careful. But they are really, really helpful. And one, I can maybe talk about one anecdote, from Photomat days, where we had one machine learning researcher building the new model with new architecture, and replacing a couple of old systems with one model, and doing it in 2 months or so. But then we had 12 engineers working really hard for 9 months to bring this into production.
Such a difference.
So what are the things that needed to happen there is entire data pipeline for acquiring data, labeling data, analyzing it, figuring out where the weak spots of the model are, entire infrastructure for serving the model, for retraining the model periodically, making sure that it's all scalable, integrating with all the other systems that were in place, putting all these loggings and alerts and monitorings, MLOps part of things, and so it was
a big project,
really big and complicated project.
Yeah.
But eventually it turned out successful.
Nice. Yeah, I mean, I think there's just so many things that are above the mathematical side that a lot of people don't even realize that are part of the process of putting something in the world, ready to go.
It's relatively easy, I would say, to build some kind of ML model prototype, but it's really hard to make it work reliably and with the good quality at scale.
Yeah, very true. And what do you think AI can help in the real world situations? Like, what kind of do you want to put your energy into, or where do you think it can kind of have the biggest impact?
Yeah, I think the biggest impact is augmenting human work, not replacing it. Replacing it for some kinds of tasks. Obviously, if you can generate some boilerplate code, it's fine to do that.
Yeah.
If you can generate some code that you yourself are confident that you are able to implement it, then that's fine. You just generate it, accept it, and move on to have more time and focus to think about really the critical parts. And it goes beyond coding. It's not just coding. It's many different, I would say, like areas of work. But here I think the critical part is to still maintain control of what's happening and to be the one who is making decisions and the one who is actually doing the thinking part.
Yeah, being the driver of the car instead of letting
Yes.
someone drive for you.
Exactly.
Yeah, incredible.
At least for now.
Yeah. Well, I think now we're not there yet where we can kind of let the models go on their own and without us having any sort of input.
I mean, there is a great progress on multi-agent systems.
Yeah.
And there are great examples of like people putting several LLM agents doing building entire apps from scratch and so on. But this is working well to some extent. This is working well for known problems. If you need to build a computer game that is the same as a bunch of other games that were in the training set, it will work.
Yeah.
Right. But if you need to do something novel, you need to do it yourself.
Yeah, exactly. Well, what's your biggest advice for a young person kind of going into this field, like where to study or what to study, and kind of what's kind of real world projects to work on to help them kind of be able to kind of do the work that you do?
Yeah, I think there's a plethora of learning material online available. Like you follow some people on social media who are producing AI machine learning content. You will really quickly figure out like courses from Jeremy Howard, lectures from Andrej Karpati, and there is a bunch of other like YouTubers and content creators. So there are many great courses from universities and so on, Coursera, etc. But eventually, like I think it's important to have some fundamental things and understandings. Like I think like high school or early grade university math is basically enough. Like it's not like really complicated. Like you can learn basics of linear algebra and calculus. That's okay. Probability and statistics. But eventually, like the best way to learn is to actually build projects, to build things. Pick something that you care about and solve that problem. And if someone is willing to do this but lacks the inspiration which project to choose, there is a bunch of examples. Like you just Google GitHub machine learning projects. There you go. Like there is a bunch of examples. You just pick one and try to do it yourself. Pick a little bit when needed, but really try to implement it yourself. And learning by doing and learning skills that are needed at that moment. I think that's the best way.
Yeah, it's true. Very exciting. Yeah. What are you looking forward to in the future, like next 5 years in AI? What's the biggest kind of breakthrough that you would wish for?
Well, I'm terrible at predictions, so I really don't know. But I would say in terms of machine learning, there is a whole bunch of things that we have not yet solved. Like from generation to generation of machine learning models, we see these jumps in performance correlated with actually end-to-end leaps. Like when you think about human cognitive process, we have sensorial input like eyes, ears, touch, and so on. And we have like our thoughts as our actions as the outcome. So that is what end-to-end means, right? And with machine learning systems, we still are not there yet. So just like LLMs are not end-to-end. Basically, there is
has to always be some sort of input.
There is tokenization. There is like positional embedding. There is like different parts of the architecture, of the transformer architecture, and there is a bunch of moving parts. So this is not end-to-end. When we think about learning of these systems, it's also not biologically plausible. We still have decomposition into training and inference. Our brains are not separated into training and inference. Like we are doing learning, online learning, right? So there is some like learning that is happening differently when we sleep, but it's not such separation. So like having systems that are able to learn continuously, online learning.
Yeah.
That's also one thing. Then there is like the entire backpropagation mechanism of how this learning is implemented. That's closely correlated with this online learning, but even that can be one step towards end-to-end. So
there's a few big
there
holes
is
here.
there is a lot of different things that I think researchers still need to figure out before we come closer to something like AGI.
Yeah. Very cool. I'm excited to see like what you do in your career, and also just kind of seeing that transformation happen and see what's going to come out of all of that research. Yeah. Cool. Thank you so much for joining us on the podcast.
Thank you for having me.
Yeah. You can watch AI Searched on YouTube, Spotify, and Apple Podcasts. Let us know what you think in the comments.